Hi everyone, and welcome to our channel Rack to Run, where we discuss with industry leaders issues around AI infrastructure and data centers. And joining us today is Joe Capes, the CEO of LiquidStack, a company focusing on liquid cooling technologies for data centers. So Joe, thank you very much for joining us today.
Thank you, Juan Pedro. Nice to be here.
Joe, what is liquid cooling and how this technology is helping AI data centers?
So liquid cooling is a means of removing heat or providing thermal management for a variety of different components within data centers. And traditionally, air cooling has been used for rejecting heat from the data center white space to the outside ambient. More progressively over the last decade, there's been a lot of R&D and investment in different liquid cooling modalities. Really, a lot of interesting work done over the last 10 years in the Bitcoin mining and crypto mining industry around using these different technologies to get better efficiency and better performance out of high performance computing. What's really happened in the last 2 years is with the advent of AI scale up and much higher power from GPUs and CPUs that are being used for this type of compute. We're seeing the adoption of direct-to-chip liquid cooling most prominently. And that involves basically putting a cold plate or a piece of very high precision metal on top of the semiconductor chip and then using a liquid or a refrigerant loop to circulate cooler fluid to the surface of the chip and then to remove the heat from the chip through a return circuit. So it's been around for a while. I mean, IBM started doing liquid cooling in its mainframe computers all the way back in the 1950s, but only until recently have we seen a wide scale adoption of liquid cooling driven by AI.
Great. Joe, and what are the most pressing pain points data center operators are facing today when they try to scale for AI workloads?
The three most pressing pain points are power, power, and power. So one of the biggest challenges at the moment is that AI factories are very power intensive. And as a result, some of the more traditional data center markets, like a good example might be Northern Virginia in the United States, has some pretty severe power capacity constraints, whether the actual power generation or things like grid interconnects. So we're seeing data center growth and AI growth in new markets. You're seeing this particularly in parts of Southeast Asia, in the Middle East, and also in South America, where there is a sufficient capacity of power. I think some of the other constraints right now are around the entire ecosystem, which provides both thermal and power infrastructure to support the scale up of AI. So, I mean, there's pressure on all sorts of different infrastructure components like not substations only, but like switchgear, transformers, backup generators, low and medium voltage switchgear is a big pain point, chillers. And in our world, coolant distribution units. So the CDUs are really kind of the heart of a direct-to-chip liquid cooling deployment. And right now, the demand outstrips the supply of these critical infrastructure components.
Great. And what are the biggest misconceptions you are encountering from operators that are still hesitant to adopt liquid cooling solutions?
Well, I think the biggest misconceptions are that liquid cooling is difficult or expensive to deploy. And I will say at the same token that a lot of the operators are deploying direct-to-chip liquid cooling for the first time or the first time at scale. And so there is a very, very steep learning curve, but the benefits of adopting or scaling liquid cooling offsets the power that's used for AI workloads. And inherently, using liquid cooling can be 40 to 50% more efficient than air cooling for these specialized applications. I think, look, globally, this is a phenomena that is new. This is the first time globally that we're seeing a massive scale up in liquid cooling adoption. There are a lot of good companies out there that are providing equipment and support. but it's really important to work with suppliers that have done this at scale and can provide not only the equipment, but also the after-sales support on a global basis.
Great, Joe. And looking ahead, how do you see the role of single-phase direct-to-chip cooling evolving? And what innovations do you think that are still needed in order to keep pace with processor heat loads?
That's a great question, Juan Pedro. I think that the next 3 to 4 years is going to see a very wide scale adoption and scale up of single phase direct to chip liquid cooling. As chip TDPs, total dissipated power, continue to increase beyond 1500 watts per chip, the challenges of rejecting that heat using a single phase heat exchange become extremely difficult. And we see the migration to two-phase technologies, whether those be direct to chip or immersion. And I think that there is a lot of opportunity over the next 5 to 10 years to explore and develop hybrid technologies which take the best of what direct-to-chip liquid cooling does, along with immersion cooling, to provide unique solutions for these higher TDP chips and high-power workloads. The reality, Juan Pedro, is the expectation is we're going to see 1 to 2 megawatt IT racks in the future. And in order to support those types of power densities and heat loads, we will need to move to two-phase.
Great. Yeah, sounds interesting. Yeah. And Joe, what challenges do you think that could most influence the adoption of advanced cooling technologies over the next years?
Well, I think some of the biggest challenges are, in the refrigerant and fluid space. It's super important that the chemical companies and the chemistry community continue to work hard on developing fluids and refrigerants that are either PFAS free or low persistency in PFAS. These particular molecules were developed to last a long time, and we depend on fluorocarbons in the manufacturing of semiconductors and cell phones and computers and all sorts of different products. But it's important that environmentally and globally we consider the environmental effects of developing these new refrigerants and fluids, which are not only appropriate for the use case, but also more friendly to the environment.
Great. So LiquidStack, Joe, has recently launched a new platform, which includes a new pay-as-you-grow model. What are the main features of this offering? And also, is this offering only available in the United States, in North America, and also in other regions?
So the platform that you're referring to is called Giga Modular, and it's available globally. We're releasing it to sale in the fourth quarter of this calendar year. And Giga Modular is a modular, scalable 10 megawatt CDU, which is designed for next generation AI workloads, particularly where operators may not know the day one scale of their AI deployments and have a sensitivity for how they're leveraging and using their capital for infrastructure to support these advanced AI workloads. And we think that having the flexibility of deploying CDUs in a modular form factor and also at a scale which supports the higher power densities that we know are coming will be really helpful in solving some of these customer challenges.
Well, really interesting, Joe. Thank you very much again for your time today.
Thank you, Juan Pedro. It was all my pleasure. It was great to have a couple minutes with you.
Thank you all for watching also this episode, and please stay tuned for more conversations around this critical space.